Take a deep breath. No, seriously, do it. Feel that air filling your lungs? The oxygen you just inhaled probably didn't come from a tree, not a pine, not an oak, not even the majestic redwood you saw on your California road trip and swore had healing powers. Because here's the truth that surprises almost everyone. Most of the oxygen on Earth doesn't come from trees at all. In fact, those leafy giants only produce a surprisingly small fraction of it. The rest? It comes from something you've never hugged. Something too tiny to see. Something oceanic. Let's break it down. First of all, yes, trees do make oxygen. Let's be clear, trees are not freeloaders. They work hard. Through a process called photosynthesis, trees take in carbon dioxide, sunlight, and water. They convert all that into glucose for food and, bonus, release oxygen as a byproduct. This is the part you probably learned in school. Diagrams with big green leaves, arrows pointing in and out, a happy sun smiling down. But here's what the textbooks often gloss over. Trees use oxygen too. Like all living things, trees also perform cellular respiration. They burn the glucose they make to fuel growth, healing, reproduction, and basically anything that involves being a functioning tree, which means they consume some of the very oxygen they produce. What's more, they only do photosynthesis during the day, when there's sunlight. At night, the oxygen party shuts down, but the respiration continues. In fact, if you've ever heard the myth that you shouldn't sleep near too many indoor plants because they steal your oxygen, well, it's not totally wrong. So when we balance how much oxygen trees make versus how much they use, the net result is much smaller than you'd expect. Scientists estimate that forests contribute only about 5 to 10% of the planet's oxygen supply. That's right, all the forests combined. So, where's the rest of it coming from? Enter phytoplankton, the tiny overachievers of the ocean. To find Earth's true oxygen machines, you'll have to go to the ocean. There, floating just below the surface are phytoplankton, microscopic marine organisms that perform photosynthesis just like plants. But unlike trees, they don't waste time on wood, bark, or annual growth rings. They're small, efficient, and incredibly numerous, and they are responsible for producing 50 to 80% of Earth's oxygen. Yes, that much. In fact, the air you're breathing right now is more likely to have come from something that looks like green slime than from the Amazon rainforest. So who are these plankton, and why are they so good at making oxygen? How something so small can do so much? First, size doesn't matter when you've got scale. Phytoplankton are microscopic, each one just a single cell, but they exist in staggering numbers. At any given moment, there are trillions upon trillions of them floating in the sunlit layers of the ocean. Because they're so small, they have a high surface area relative to volume. This means they absorb sunlight and carbon dioxide with incredible efficiency. No bark to maintain, no roots to feed, just pure, streamlined productivity. Second, the ocean covers over 70% of the Earth's surface, which means phytoplankton have way more room to work than forests do. They don't take weekends off. They don't need fertilizer. They're basically the 24/7 workaholics of the biosphere. And unlike trees, they don't hoard the oxygen they make. Most of it gets released into the surrounding water and gradually makes its way into the atmosphere, right into your lungs. But why don't we hear more about them? Because phytoplankton don't have good PR. Trees are charismatic. They're tall, photogenic, and often featured in children's books as wise elders with deep voices. Phytoplankton? Not so much. They're invisible to the naked eye. They float. They don't do anything impressive looking, and they don't show up on Instagram as well. But make no mistake, they're the backbone of life on this planet. Not just for oxygen production, but for supporting marine food chains, regulating carbon, and shaping global climate. In short, phytoplankton are like the unpaid interns keeping the Earth running while trees get all the glory. So what happens if they disappear? This is where things get dark. Because phytoplankton are so sensitive to temperature, acidity, and pollution, they're vulnerable. And right now, many of them are in trouble. As oceans warm and acidify due to climate change, plankton populations are shifting. In some regions, they're declining. In others, harmful algae blooms, essentially phytoplankton gone rogue, are throwing ecosystems out of balance. If we lose too many plankton, oxygen production could drop. Not immediately. We'd still have breathable air for centuries, but the long-term stability of our atmosphere would be compromised. Plus, the effects wouldn't stop with oxygen. Phytoplankton also absorb massive amounts of carbon dioxide. Without them, more CO2 would stay in the atmosphere, accelerating global warming. In short, protecting phytoplankton isn't just about breathing, it's about everything. What about the rainforests? Ah yes, the Amazon, often called the lungs of the Earth? Well, it's complicated. The Amazon does produce a lot of oxygen, but it also uses most of it. The ecosystem is so tightly balanced that its net oxygen output is surprisingly close to zero. However, that doesn't mean it's unimportant. The Amazon plays a critical role in carbon storage, rainfall regulation, and biodiversity. It supports millions of species, many of which we haven't even discovered yet. So yes, save the rainforest, but not because you're worried about running out of air. Do it because it holds half the planet's life forms, and because it's one of the most awe-inspiring places on Earth. How did Earth get so much oxygen in the first place? To really appreciate our oxygen-rich planet, you have to realize it wasn't always this way. In fact, for the first couple billion years, Earth's atmosphere was basically a hot, gassy mess. No oxygen, no ozone, no breathable air, just methane, carbon dioxide, nitrogen, and the smell of existential dread. Life existed, but only in the form of anaerobic microbes, tiny organisms that didn't need oxygen and frankly would have died if you gave them a whiff of fresh air. Then came a planetary game-changer, cyanobacteria, aka blue-green algae. These microscopic innovators showed up around 2.5 billion years ago and started doing something radical: photosynthesis that released oxygen as waste. At first, the oxygen they produced didn't go into the air. It bonded with iron in the oceans, forming massive rust-colored deposits. This went on for millions of years. Basically, the oceans were one giant chemistry experiment where oxygen kept getting soaked up like a sponge. But eventually, all the iron was used up, and when there was nowhere else for the oxygen to go, it started building up in the atmosphere. This moment is known as the Great Oxygenation Event, and it was kind of a disaster when oxygen almost killed everything. You'd think oxygen showing up would be a good thing, but for most life at the time, it was the apocalypse. The majority of Earth's organisms were anaerobic. Oxygen was literally toxic to them. As oxygen levels rose, they either died off, adapted, or retreated into oxygen-free environments like deep ocean mud and weird sulfur vents. It was a planetary reboot, a mass extinction caused by photosynthesis. So the next time you see a plant, just remember, its ancestors were chemical terrorists to the early Earth. But out of this chaos came opportunity. Oxygen allowed for more efficient energy production, bigger, more complex cells, and eventually, multicellular life. You know, animals, including us. Oxygen wasn't just a gas, it was the engine of evolution. Why Earth is a rare oxygen paradise? So here's the big cosmic question. Why does Earth have so much oxygen while other planets don't? Mars? Barely any. Venus? Also nope. Even planets with atmospheres don't have breathable air. It turns out stable oxygen in an atmosphere is weird. Oxygen is highly reactive. It wants to bond with everything. Metals, gases, you name it. That means you need constant photosynthesis to keep the levels high. Earth has that. Thanks to liquid water, life, and the right temperatures, we've kept the oxygen flowing for over 2 billion years. But it's a delicate balance. If life vanished or if photosynthesis stopped, the oxygen in the atmosphere would start reacting with rocks, volcanoes, and decay, and within a few million years, it would be mostly gone. In other words, oxygen isn't just a natural feature of Earth. It's a life-created phenomenon that's constantly being maintained by microscopic workers, and most of them are floating in the sea. What if we lost the oceans? Let's go full doomsday for a second. Imagine a world where the oceans become too warm, too acidic, or too polluted to support plankton. The great oxygen engines of the planet start to shut down. At first, we wouldn't notice much. Oxygen doesn't just vanish overnight, but over decades and centuries, atmospheric oxygen levels would start to dip. At 21% oxygen, our current level, things are perfect. Drop it to 17% and you'll start gasping while jogging. Drop it to 10% and your brain gets foggy. Drop it to 6% and fire can't even burn. Now imagine society trying to function with half its population feeling faint, aircrafts unable to take off, and cigarettes just silently smoldering in ashtrays, wondering what went wrong. We'd survive, but we'd be uncomfortable, unproductive, and probably very cranky. So, yes, hug trees, but don't forget the slime. It's easy to romanticize forests. They're visible, they're majestic, they change colors in fall and provide shade in the summer. But the truth is, if you care about the air you breathe, your real gratitude should go to the things you can't see. Phytoplankton, cyanobacteria, diatoms, the silent, slimy, microscopic oxygen machines of the sea. They don't win awards, they don't get planted on Arbor Day, but they've been keeping this planet breathable since long before mammals even existed. So the next time someone says, we should all go plant a tree, you can say, sure, but can we also fund marine microbiology and reduce ocean acidification? And then just walk away like you dropped the mic at an environmental science TED Talk. One last breath. It's kind of poetic when you think about it. Every breath you take is a recycled gift from ancient bacteria, from dead plankton, from oceans that shimmer under the sun. It's not just oxygen, it's survival, it's history. It's the quiet miracle that lets everything else happen. And chances are, it didn't come from a forest. It came from a speck of green green in a vast blue sea.